Imagine objects floating in midair, defying the law of gravity. No, we're not talking about magic. This is the power of electromagnetic levitation. Picture this, an object suspended, hovering as if by some unseen force. But it's not a trick or illusion, it's the science of electromagnetic levitation. At its core, it's the repulsion between magnetic poles that makes this fascinating feat possible. So, it's not magic, it's science. But how does this fascinating phenomenon work in more detail? Electromagnetic levitation, as the name suggests, relies on two key things: electricity and magnetism. But how does this work, you ask? Well, let's dive into the world of physics to understand this fascinating phenomenon. First, let's talk about electric currents. When an electric current passes through a wire, it generates a magnetic field around it. This is a fundamental principle of electromagnetism discovered by scientist Hans Christian Ørsted in the early 19th century. Now, let's add levitation into the mix. Here's where it gets really interesting. If we design a system where the magnetic field generated by the electric current is strong enough, it can actually oppose the force of gravity. This opposition creates a lifting force. So, essentially, we're using magnetism to fight against gravity, resulting in levitation. You might be wondering, where do we see this in real life? Well, magnetic levitation, or Maglev trains, are a perfect example. These trains are designed to float above the tracks, eliminating friction and allowing for speeds that conventional trains can only dream of. And then there are hoverboards. Not the ones with wheels, but actual hoverboards that float above the ground, like something out of a sci-fi movie. Incredible, isn't it? But wait, there's more to it than just opposing gravity. Electromagnetic levitation isn't just about floating objects. It's about pushing the boundaries of what we thought was possible. This technology is being harnessed in more advanced ways than you might imagine. In the realm of material science, it's used for containerless processing. This means substances can be manipulated without the interference of a physical container, allowing for a level of purity that was previously unimaginable. Then there's the field of space technology, where electromagnetic levitation provides a unique solution for satellite propulsion. By eliminating the need for fuel, it paves the way for more sustainable and efficient space expeditions. But the story doesn't end here. The potential of electromagnetic levitation technology is vast, with implications far beyond what we've discussed. It could revolutionize industries, spark new scientific discoveries, and challenge our understanding of the physical world. So now that you know a bit more about electromagnetic levitation, here's a question for you. Can you think of any other potential applications for this technology? Share your thoughts in the comments below.